Now we will discuss context windows. So see, every large language model has a context window, and context window is the maximum number of tokens it can process. So maximum tokens a large language model can process at a time is the context window. So context window, it represents the total amount of information the model can hold in its head at any single moment to generate a response. So context window is the active memory. So whatever is loaded in the context window will be given as a prompt to the large language model. And whatever is there in the context window, large language model will consider each and everything while generating the response. So whatever is there in the context window will be processed by the large language model. So it is like the total amount of information the model can hold in its head at any single moment to generate a response. Now we know that foundational models are stateless. So because foundation models are stateless, the context window is the only space where the agent's intelligence meets your specific data. Because large language model on their own, they cannot store any information. So context window, the active memory, the short-term memory is the only place where we can give it some context, where we can store some past interaction, some user preferences, some system prompts, so that the large language model, while generating the response, will consider those things as well. So foundation models, any large language model you take, they are stateless. They don't have any prior memory of you. Every query to a large language model is a fresh, it's stateless. But with context window, we can give it some information about the past interaction, user preferences. So context window will give it some more intelligence. So context window is the active memory, like the stuff which the large language model will consider, will process while generating the response. And in the context window, we can store whatever we want, like the input prompt, system prompt, some user preferences, some images, documents, links, anything you want to store, you can store. Now, context window has got a size. It depends on the large language model. For some, it is like 32K tokens, for 128K tokens, 256K tokens, like that. Now, what exactly that context window might contain? So, context window, it holds the system prompt. And what are system prompts? System prompts are basically the instructions. And system prompts are always present in the context window. System prompts, they take the permanent space. System prompts are basically the instructions given to the large language model to behave in a certain way. We give special instructions to the large language model, like the response should be in this format, or act like a senior software engineer. So special instructions we give to a large language model is the system prompt, and system prompt is something which will always be there in the context, which will occupy the permanent space in the context window. So the idea is that for every query given to the large language model, this system prompt will be taken into consideration so that the response will strictly follow the system prompts. So context window will contain system prompt. Context window will contain the user inputs, and the user input will be like your current question or some document uploads. So that will be the user input. Context window also contains the history, like the previous interactions, the history, the memory, like the past back and forth turns that provide the flow of the chat. And context window also contains the tool outputs. Like if we are calling the tools, the response of the tools, so the large language model will call a tool will get executed, it will generate some response, it will send back that response to the large language model. Now we can store that outputs of the tool, the responses of the tool in the active context window. So context window also contains the tool outputs, like the raw results from the search or code run. So these results are poured into the window so that models can read it. So the tools, what they do is that the output of the tool, we directly store it in the active context window so that we can very easily send it to the large language model. So now it's very clear that if I talk about context window contains the system prompt, instructions given to the large language model, user input, history, the memory, and the tool outputs. Now let us discuss the context problem. Context windows problem. Now we know that the context is limited. Like any large language model you take, the size of the context is limited. For example, the context window can be of 128K tokens or 256K tokens. So context window is limited. So what happens is that for long conversations, this context window will overflow. Because of the limited context window, for long conversation, it will start overflowing. And the overflow problem, let us discuss. So when the conversation exceeds the limit, like when the context window gets fully filled up, the system faces a hard ceiling because context window is fully occupied. Now there is no space is there to add more information in the context window. So to keep working, we have to flush out some information from the context window to make room for the new incoming information. So that's the overflow problem. Like when the window gets fully filled, it gets overflow, and we have to make room. We have to make some space so that we can keep on adding the incoming information. So you like the in context window, it follows the first in first out. So the idea is that whenever the overflow occurs, the oldest information, it gets flushed out. So usually the oldest messages at the start of the chat are deleted to make room for the new ones. And because of that, we see something called as the goldfish effect. See, the idea is that because the oldest information got deleted, agent will start forgetting that. So suddenly you will see that the agent forgets the project requirements you gave it 20 minutes ago because those tokens were pushed out of the window. So this is what is the goldfish effect is. So goldfish effect means because of the overflow problem, to make room, the oldest messages, they are flushed out from the context window, and because of that, agent will start forgetting those information because it's not there in the memory. And we see that agents start forgetting the starting conversations, and that is what is the goldfish effect is. So we saw that context is limited. So since context is limited, there is a problem of overflow. Also, context is expensive. Context is expensive. So there is a computational cost associated with the context. So more tokens, if we keep on increasing the size of the context window, then definitely we will be needing more compute, GPU power to process. So as we keep on increasing the context window, the computational cost will increase. So more compute, GPU power. So more tokens implies more power. So that's why context is expensive. Latency. 100 token prompt is nearly instant, but 100K token prompt can take over 30 seconds to process. So the idea is that as we keep on increasing the context window, the latency will increase. Because just imagine 100 token prompt. Definitely it will be very fast. Instant result we will get. But for 100K tokens, it will take lot of time to process. So latency will come into picture. And financial cost. So see, the idea is that most API providers, they charge by the token. Filling the window is exponentially expensive. Filling the window is exponentially expensive because the idea is that if we keep on increasing the context window and if we just keep on filling the context window and giving it to the large language model like Google Gemini or GPT, Claude, then the API charges will increase exponentially because API providers, they charge by the token. So it's very clear that context is expensive. The computational cost is involved, latency is involved, and financial cost is involved. So now it's very clear that context window is the ultimate bottleneck of an AI agent. You cannot store everything in the context window because of the limited window size. We cannot store everything. And this is why we cannot give a large language model a 1000 page book and we ask it to remember everything forever. It cannot. After a time, it will forget because of the limited context window size. So what's the solution? Solution is the long-term memory. Long-term memory is the solution. So long-term memory is something like a permanent database, an external memory, a permanent memory, permanent storage. So we have to make use of a long-term memory like a vector database. And this long-term memory can store the information forever. So this long-term memory acts like a library where only the relevant books are pulled into the workspace, the context window as needed. So the idea is that the long-term memory will store everything. It will remember everything forever. And whatever we need in the context, we can just pull it from the long-term memory. So long-term memory is like a library wherein we can pull relevant books as needed into the context window. So context is valuable but scarce because we know that context window is limited, but we can handle it and we have to make use of the long-term memory and just pull relevant information in the context window when and where needed. Now we will discuss the token economy. The token economy. So the large language models, they don't count words, rather they count tokens. And what's the difference? Tokens are like chunks of characters. So if we just try to compare tokens with the characters mathematically, so mathematically we can say that 1000 tokens is approximately 750 words. So 1000 tokens is roughly 750 words. And if we discuss the limit, we know that there is a limit on the context window. Context window is limited. So that is what we are discussing. So if we take this bucket, it is like a context window. So 128K token limit. So in the context window, we can only add 128K tokens. And if we are trying to add more, it will start overflowing. So if a large language model has a 28K token limit, like GPT-4, it can process roughly 300 pages of text. While that sounds like a lot, a single complex task involving large PDF analysis and long chat history can fill that space surprisingly fast. So the idea is that 128K token might look a very large context window size, but in reality, it is very less. Any complex analysis you will do or a long chat interaction, this context window will start overflowing. And then we have to make use of the long-term memory so that whatever important information we feel like is getting overflowed, we can store it in the long-term memory, and we can retrieve it when and where needed in the active context window. So now it's very clear that any large language model you take, the context window size is fixed, it's finite, and the costing, the API charges are based on the tokens, and the calculation is done not based on the words but based on the tokens. For example, for GPT-4, the token limit is 128K. It means it will be counting tokens like 128K tokens it can store. And if it's trying to store more, overflow will occur. So this is what the token economy is.